Welcome to the JVM Languages Script Bowl for Java 1 2014. How many people have been in the Script Bowl before? You know the drill. Okay. Wow.
Me too.
Yeah. Well, originally the schedule, we had Rax as the moderator. Unfortunately, he couldn't make it. My name is Andres Almiray. I'm a Java champion, but that's not important. What is important are these
Why
four
do you say
guys right here on stage. These guys, their job today is to showcase their particular language. They want the language they are championing, and finally woo you into trying one of these languages. At the end of the session, we'll have time for questions. We will go for with a first round, 5 minutes each. They will show what the language can do, and then you go for the second round, 6 minutes, when they will do the best they can to showcase why their language is the best one. Then we break out for questions, and finally we do the voting. So how many claps we get will determine the winner of the Script Bowl for this year. Clear? Perfect. So let's get started. We will begin with Groovy, then we switch to JRuby, Clojure, and Scala. So please, gentlemen, introduce yourselves, and then we'll go.
So hello, everybody. I'm Guillaume Laforge. I'm the leader of the Groovy project. I've been working on Groovy for more than 10 years now. The whole introductions, yeah?
Yep.
I'm R. Tyler Croy. I'm part of the JRuby community. We've been using JRuby where I work for about 3 or 4 years, migrating from Ruby to a higher performance VM. So I'm pretty happy to be here.
Hi, I'm Priyatham, and I've been a Java developer for 12 years now. Fairly new to Clojure, and I've been doing it for less than 2 years, Clojure and Clojure script, and I'm an independent consultant.
I'm Ryan Knight. I've been doing Java development for 15 years and Scala for 2 years. I now work for TypeSafe, which is the company behind Scala. So I do training and consulting for them around Scala.
All right. So let's begin with Groovy. Guillaume, you have 5 minutes.
Okay, thank you. So, Groovy is a pretty agile language. You see the kind of stuff you can do with using Groovy, right? So for this first round, I'd like to I'd like to cover 2 new things that are here in Groovy 2.3, the recent release, and 2.4, the upcoming release. So that's the Android support coming in 2.4 and traits in Groovy 2.3. So a few words about the Android support. So it's pretty new, and there are some very interesting links there if you want to learn more about it, because I'm not going to dive too deep into it. But I'd like to mention that just this summer, the New York Times, which announced that they are switching to Groovy and RX Java for creating reactive applications. And so this is the blog post where they talk about it. And they were showing some examples, like with Android, you've got tons of anonymous classes everywhere. Oh, sorry. Just for doing something simple as returning some value in this example from their blog post. And when you go to Groovy with the fact that it's got closures, you can write much more concise code, and you can get rid of tons of anonymous inner classes. So it's just one little aspect of it all. But they were really selling their choice of Groovy by saying that it made the code much more concise, more readable, and Groovy can be as type-safe and as, so no pun intended, and as fast as needed, thanks to the recent transformations like type-checked and compiled static. And, you can find some examples of that with an open source application. And the other feature I wanted to mention, that's traits. So it's a bit like interfaces, but with method bodies. It's close to Java 8 interface default methods, but they are not supposed to be used for traits. It's a nice way of composing behavior, and our traits are also stateful, and it works very well with our static features. And just to show you some examples, here I've got a trait representing the flying ability, so something that can fly, so it looks like an interface but with a method body. A bird can implement that trait, can create the bird, and then the bird inherits from that behavior from the trait. Okay. But you can also have inheritance between traits. No, that's not what I was. You can implements. You can mix stuff like named arguments, and the other one I wanted to mention is this one. Even in the case you've got the same methods in two traits. So here you can see that I'm extending a class and implementing two traits, so I can really get behavior, orthogonal behavior potentially from different traits. And there are some rules here. That's the last which wins, but you can also make it explicit by overriding surf in your own class. So that's basically it. And if you want to dive more into the new features in Groovy, I'll be doing another talk at 4:30 about all those cool features.
You have 1 more minute.
One more minute? Oh, okay. I was afraid of going too fast. What else could I say? So Groovy is great, and has always been great for... wait. So it's not just... It's great. I'm justifying why it's great for the interoperability story with the Java language. So you can really mix and match both languages together. And also, how close it looks to Java itself because of the grammar, which is really deriving from the Java grammar. So that's been one of the key selling points for the Groovy project. And that's it.
All right. So now is the turn for JRuby.
So I'm a fool, and I'm going to do live demos and live code for you guys. So we'll see how this goes. Unlike some of my predecessors before me, I am going to try not to lose as bad to Groovy this year. So we'll see what I can present.
It's up to you guys.
So I'm using this REPL called Pry, which is a really great tool in the Ruby community. This is all running on top of the JVM, and I've defined a class here. And Ruby is an extremely versatile and flexible language. So I can obviously just call greet and get my little greeting. But Ruby also supports dynamic method invocation, which means I can send a message to the class greet and get the same behavior. Now this is extremely, extremely powerful. In some cases it can be used for evil. Only use it for good. If you want to know some tools that are using it for evil, you can come ask me afterwards. But what I really wanted to talk about here was some of the interop with the Java ecosystem, which is where I think JRuby really, really shines. So I wanted to print an ASCII table for my demo, and so I searched the internet, and of course I downloaded the first jar file that I could find, and I'm going to go ahead and load that into my Pry REPL here. And JRuby has this great support for treating Java code very much like Ruby code, so it's very familiar, so your language and your interfaces look the same whether you're talking to Java code or Ruby code. So I'm requiring this jar that pulls it in. Then we've got a Java import method which will pull the ASCII table class into my current scope, and this is all coming out of this jar. I'm defining some Ruby arrays with some information. I've defined this nice, helpful little method. And one of the things that this little method is doing is it's calling ASCII table.instance.get_table. What JRuby provides for us is it treats Java conventions and it'll proxy Ruby conventions over to Java conventions. So ASCII table defines the get instance method, instance, which will return an instance of that class, but JRuby will proxy automatically .instance, which is the more idiomatic Ruby way of accessing that same method. The same for get_table. All these camel case methods in Java come over into Ruby land looking very much like Ruby. So that's just a very, very simple, quick demo of how we can pull in Java code from random sites on the internet and execute it and treat it just like it were Ruby code. One of the other really great features of JRuby specifically, and I'm flattered there's some JRuby people here, I'm flattered that Oracle decided to copy some features from JRuby for Java 8. For the longest time, JRuby has proxied blocks, which are a Ruby construct, into anonymous classes when invoking Java code. So I've got this invocation of Java lang thread, its constructor, which you can pass an anonymous class that implements a runnable interface. And with JRuby, I can just pass a Ruby block directly into that constructor, and JRuby will handle the management of that. And I can use any anonymous class interface in Java just like I would in Ruby by just passing blocks around. One of the most impressive features to me of JRuby, however, is its embeddability. The way that JRuby operates is in this runtime, in this pry environment right now, I've got a JRuby runtime. And that JRuby runtime is something that I can further use within my code. Let's see if I can remember what file I'm loading here. So I've got this turtler Ruby script, which creates a new JRuby runtime, executes some Ruby code into it, and then also executes outside of it. So outside, in the outer runtime, I've got a constant defined, which is version 1. And inside the runtime, I've got a constant defined, which is version 2. Which means I can provide full environment separation between JRuby runtime environments in Tomcat or Jetty or another different kind of, or another JVM server. And I'll talk more about that in the second component. But just to show you what this code actually looks like, it's a very, very simple API. We can import the Ruby class, and we can create a runtime and an evaluator, and you can start evaluating Ruby code in your JVM-based projects, whether it's Groovy, Scala, Clojure, etc. You can use JRuby in any one of them. That's it.
Yeah, we're done. So let's switch to Clojure now.
I just want to say that I am a mediocre engineer. I failed to give the right estimates. I failed to ship code without bugs. I failed to do the right thing when the manager says, just do it. Just fix it right now. I've been a lead Java engineer for over a decade, and I've been doing JavaScript, Python, Groovy on the side as well. And I've been pretty good at it, or so they say. Frankly, I'm not that good. Today, I want to show you my journey into Clojure, how it changed my life, and I hope it will change yours as well. My first demo is a single-page reactive app with Clojure and ClojureScript. My second demo will be the part 2, but we'll get to that later. So I just created this as of yesterday. We use Lenigan, which is similar to Maven. It's a starter. It's a build tool. So we just say Lenigan new Ringo script ball, and it just created a project. I just want to show you what a project structure looks like, because if you're coming from Grails or Scala or using Play or even Node.js, you will see a structure. There's an API. Everything is built in. This is obviously an example. We can change this. There are routes built in. This is the router. Don't worry about the braces now. We can talk after the discussion. But basically, the out-of-the-box comes with routes. It comes with an async HTTP server out of the box. It has a design with a less bootstrap workflow. It has resources with an index HTML, which comes with H5, and Bootstrap as well. And there is ClojureScript code, which is client components, utils, and we'll see that later. But for now, since we're running out of time, I actually created a demo for you guys. So let's just switch right into that. It's created with the same workflow. So this is this is running. All you do is lane Ringo, and then it shows up. So this is what the page looks like. And I want to show you one thing, what reactive means in Clojure land. So this is a simple page, which has a sign-in OAuth Twitter button and has a graph. Right? It has a graph which has some data and is showing up. Well, that's all good. You can put that in any app. But look at how things change right now. So what if I want to change the data and I don't want to reload anything, right? So let's say I want to change something like, well, let's just change the numbers. This is just a dummy database, but you get the idea. I just saved it. And now since it's a backend, I just have to refresh the browser. Normally, if it's a front end, it doesn't have. See, the graph just changed. I didn't do anything. What is happening behind the scenes is Ringo, as in, this is just a name I created. It's just Lenigan plugin. It is compiling assets, front-end assets. It is compiling the routes. It is compiling Clojure. It is compiling Clojure script, all behind the scenes. You don't have to worry about that. You just keep it running. So that's obviously a basic example of a data change and how things change live. I also want to show you how Clojure script can be even more reactive. So let's say I want to put something below this guy. Let's just put a hello world. How does that work? So in my index, this is an HTML of this page you're looking. So you see that? Clojure builds on the strength. So let's just put a counter. So I have an ID. I have to inject that. So if you're used to Angular, this is kind of a concept, right? So I will just create, I'll go to my components. We'll have to... There you go. So I added a widget.
1 minute.
It's called div hello world, right? I'll just evaluate it. And I added, forget about the code for now. All it's doing is like jQuery, $hello injected. You want to see? That's it. Imagine building components like this, live. Right? So that's just one. That's just a few things. You can, now what I'm using is, and I have to mention this because this is possible because of OM, which you might have heard. It's a wrapper on React.js, which is the biggest thing out there at this point. If you want to build user interfaces small and build on top of it, that is the way to go. And OM makes things even better because it's built out of immutable data structures, et cetera, but those are just the details that make things possible. And I want to show you one last thing, is you've seen live, you've seen the structure, you've seen the database. So what about adding the real database?
And we switch to Scala.
We'll do that in part 2. Thanks.
I want to kind of take a little bit of a different approach. I want to just kind of step back a little bit and talk about how the rules of the game have fundamentally changed. If we look at applications that were written from the 60s to the 90s versus apps that are written today, what they run on is completely different, right? We went from single machines to clusters of machines, right? Single core to multi-core. And all this is enabled in an entirely new class of applications. And what's really different is that, you know, in the year 2000, there was approximately 350 million people on the internet. Today, Twitter alone handles approximately 200, they say they have 215 million active users on a monthly basis, and that's all being run off of Scala. So the amount of users that we have to handle, the type of application we have to build is so fundamentally different. I think it requires a completely different way of thinking about how we build and architect our applications. And so I think what you should really think about is choosing your language on what it enables, not on specific, you know, features and functionalities and what's cool and neat, but what kind of applications does this language enable you to build? And I think that's why Scala is so fundamentally powerful, is it enables an entirely new type of application to be built. And the fundamental thing with Scala is that it makes it easy to scale your application. So, and there's a lot that goes into making an application scale, but at the core of fundamental architectural principles, Scala makes it really easy to scale for a number of reasons. I'm going to talk about those really quickly. The first is, well, I guess let me say one thing. Scala is fully type safe. It's compile time checked. It's fully interoperable with Java. It blends an object oriented with a functional model, so it's very easy to work with any kind of existing jar files, Java classes, anything that's out there. Makes it really easy. But on top of that, it adds a lot of neat features. The first that I want to talk about is immutable data. So one of the killers of being able to scale your applications to dealing with mutable data. If you want to scale to a very large number of users, a highly concurrent application, you need to have your data. You don't want to deal with shared mutable state, trying to share it between threads. You want your data to be completely immutable. So Scala has a built-in data type. The val means that value is immutable. It will never change. And that means I can share it between multiple threads. I never have to worry about who is going to be changing it. It also has immutable data structures. So this is one example, an immutable index sequence. So I create this index sequence. It's never going to change. I know the values in it won't change. And so I can share that data structure between multiple threads. The other thing is functions as first-class citizens. This is key to building this entirely new class of applications that are event-driven, scalable, because what functions enable me to do is to build small blocks of code that I can schedule and run in an asynchronous context. The next part of it is expression-oriented. So everything in Scala pretty much returns a value. So, and you combine this with things like pattern matching, it becomes really powerful. So with Scala, a pattern matching actually returns a value. So here we're doing a match on the POS. We're saying POS match, and depending on what kind of position we have, we want to return a different value. So here, if it's a user position, we want to create an object based on the timestamp. If it's a cluster position, we want to do it based on the timestamp and the count. And we're going to take the value returned from that pattern match and set it to the val properties. So val properties is this immutable value that's getting the result set from the pattern match. And what's really nice about this is it makes it easy to reason about because there aren't side effects. I don't have to use a temporary value to store my values in. The last part is for expressions. With the for expression, what's really nice with this for expression is here I'm creating two futures. I'm doing two web service calls. Those web service calls are making a future, returning a future. And I want to combine those results together, compose them together, and return the result to the end user. Right, so I'm saying, I get the future of the TypeSafe website, the future of the Twitter website, combine those results, the bodies of those results, and return to the end user. Again, this makes it, the really neat thing about this for expression is it makes it really easy to work with and reason about futures. That's one of the most challenging things about a highly concurrent application is how do you deal with, reasoning about, your logic in your program. Here, this future...
1 minute.
Makes it really easy to see the control flow and how things flow. So I want to give you an example of one example of an application, and then I'll do another one on the next. So here is one type of application that's really enabled by Scala, and that's very much of a push-based, event-based model that pushes the data in real time out to the client. This is simulating a stock flow.
There's something happened with your video. We're seeing the other screen.
Oh, all right. Well, we'll show it on the next round. I'll be sure in the next demo we'll show it. So Scala enables very much of these reactive event-driven applications because you can use these functional concepts to create callback code. So when an event happens and fires off, it says, let's call this function, and the function can be a value that gets returned up to the client. It makes it really easy to reason about, too, because those functions use immutable data, so you don't have to worry about global state, shared state between different functions. So.
Okay. So that concludes the first stage. And that's number 3. Okay, so now that you have seen what all these 4 languages are about and some of the initial features, now it's time for the big leagues. Now it's time for these guys to woo you and get into their language. So without any further ado, let's get ready to rumble. Guillaume, take it away.
Woo! So this is, well, for me, that's what I usually call a community round in the sense that it's not just about the language, but the community and what other folks are doing, etc. And also, as I ran a bit too quick in the first round, I really wanted to show you a bit more of the Android support. So I have this little demo here. I've got a 6-year-old who's learning how to read, and I wanted to create a small application for her to help her, read words. So I obviously did it in Groovy and on Android. And this is, so it's showing up some words, and you can, so I don't know if, if I put the sound up a little bit, I'm using the mic. I don't know if do you hear that or not? Yeah, well, so it's using, text-to-speech, etc., using different fonts for handwritten versus script kind of stuff. You can add, if I click there, you can add new words and uncheck, etc. words, so she can, try new. Oops. So the emulator is never responsive. It's coming. Ow. I should be using Genymotion, but I can remove things, etc. And I just wanted to show you the code. So there are just like a handful of classes and some things that Groovy make simpler. For instance, where you want to repeat the same method on the same object all the time, you can use with. So it's a bit for those who remember Pascal or such languages. We've got that construct. It takes a clojure as parameter. Or what's cool, we've got the Elvis operator here because it looks like an Elvis smiley. And so if the list is non-null, non-empty, etc. It's going to return that stuff on the left, or otherwise a default value. What else? Also things like for running stuff. So for those who know Android a little bit, things like that can be a bit painful to do. For running stuff in the background, you just call the run on UI thread and pass a closure, and that's just working out of the box without particular magic. And I think there was another little thing I wanted to show you. What was that? Yeah, well, never mind. That's about. Oh yeah, that's for reading the files. Where is that? I'm lost, although there's not much code. Yeah, here, for instance, I can read an asset, which is in the form of a file, pretty easily with just, okay, I open a stream of the file, and with the stream, I create a reader on top of the input stream and read the content, etc., to load the list of words. If you do it the Java way or the Android way, it would be much more verbose. So that's the first little demo I actually wanted to show in the first round, but I'm showing it now. And the other thing, so where is it? It's here. I would like to mention that particular community project. It's called GrooveScript. Any modern language now should be able to compile into JavaScript code. That's the new, bytecode of the modern age. And so it's called GrooveScript. You can go to groovescript.org, and it's got lots of great tutorials, demos, etc., with things like Node.js, Meteor, React, etc. So I really invite you to have a look at that. And it's nice because you can also use Groovy in the front, in the back, and it's all turtles all the way down. And I've got a little demo, which is actually, first of all, a question: who knows who's painted that? Yes, and my Clojure colleague might remember it because there's been a cool Clojure demo about that. And the guy who did the GrooveScript project. So let me show you the GrooveScript website here. In the list of demos, there's this Jackson Pollock demo here, which is actually inspired by the existing Clojure demo. So I'd like give to Kaiser what belongs to Kaiser, right? So it's building, it's a painting, Jackson Pollock painting, and with just a couple of, so is the Vim, do you see that? Yeah. So it's just a couple of classes, draw Groovy and functions Groovy. And although it's Groovy code, it's going to be compiled into JavaScript code and it's going to run in the browser. And you can also, so the syntax highlighting in Vim is a bit weird because it's the same color there. Okay. And so this is going to be converted into JavaScript. And what I also wanted to show you is that you can also, a bit like what GWT or GWT, whatever it's pronounced, was doing, you can also define native stuff. So you can even embed some JavaScript in the middle somewhere. And well, that's basically it. That shows a cool little demo, but there are many cool demos on that website for GrooveScript. So that's a nice community project among the many cool projects like Gradle, Grails, Jeepers, and so on. Thank you. And Griffin. Sorry. Oh, I forgot Griffin. Should have named it.
Could too. It's too brutal. Okay, so that concludes Groovy, and now we go with JRuby.
One of the things I wanted to make sure that I said while I was up here is how honored I am that JRuby is sort of considered among the echelons of Scala and Clojure and Groovy and all these great scripting languages. And there's a lot of members of the Ruby community, not the Groovy community, that are definitely taking notes on some of the cool things that are being done in these other scripting languages. So I wanted to call out one gem in particular called Concurrent Ruby, which has very good support on JRuby, backing a lot of the task pools with native Java thread pools that implements a lot of concepts from Clojure and Scala and Akka and brings those into the Ruby environment. So I just wanted to say thank you to everyone in the respective communities, because the presence of all these other communities have made Ruby better for me, and at the end of the day, that's what's most important to me. So I mentioned earlier that I wanted to talk more about how Java and Ruby can get along well together and why that makes JRuby a very compelling choice. This is rubygems.org. It's sort of the main home of a lot of the community source code for the Ruby community. And if I'm to take their statistics by their word, there's 89,000 gems available. And so that's 89,000 different pieces of software that are available for you as a Ruby developer or as a JRuby developer. And then Maven Central allegedly has 87 some odd thousand artifacts available that you can also consume and use within the JRuby project or within a JRuby project. And there's some really great tools that are starting to come of age in the Ruby community. After rebelling against Papa Java for so long, we're starting to realize that some of the tools that are available in the Java community are actually really useful and maybe not so awful after all. One of those tools is the Maven repository concept and how Java developers generally declare dependencies. One of the JRuby community members, a guy named Christian Meyer, working with the Torquebox project, created this server called RubyGems Servlets, which will take any RubyGems repository and present it as a Maven repository. And what that means is I can use Maven or Gradle to start to resolve both my Java-based dependencies, but also my Ruby-based dependencies with this useful little servlet. Taking that a step further, there's another project which, full disclosure, I am involved in, called the JRuby Gradle project. I've been enamored with Gradle. It's a fantastic tool, and I really want us to have that too in the Ruby community. And so there's a couple folks in the Ruby and in the Gradle communities that have been participating with this. And because we can now pull in Ruby gems just the same way we would pull in Maven dependencies, all of a sudden Gradle is opened up for me in the JRuby environments to where I can take all of the great tooling from Java without necessarily needing to use Java itself. I wanted to show a quick demo of what this means. There's a member of the ASCII Doctor community, which is a great tool that uses Ruby and JRuby. ASCII Doctor J actually embeds JRuby inside of it. One of the members of that community, a guy named Shulk, that's how I'm told it's pronounced, I guess, built the JRuby Gradle jar plugin. And so this is a jar that is pulling in JRuby as a dependency. It's a fat executable jar. And what's happening here is this line is being putsed, so using the Ruby put statement and the colorized gem to create ANSI color sequences and executing that all from within a jar that was built by Gradle. And so the Gradle file for that is very straightforward. We pull in a couple of great Gradle plugins that the Gradle community has developed. Like there's the basic Java plugin, and then there's this shadow jar plugin, which makes fat jars very efficiently. We can also specify our Java dependencies, like the JRuby complete jar, which is here. And we can also specify gem dependencies, which means I can slurp both of those into a build project at the same time. I can start my init script, which is, let's see if I can find it, resources, which is just a Ruby script. That's all that's running in this fat executable jar. And then we're relying on Shadow Jar to actually build the jar for us with a little custom Groovy scripting on top of that to pull in Java and Ruby into this one executable jar. And so this JRuby Gradle project I'm very excited about. I think it means that you guys and the Ruby community will be working together a lot more in the future. There's some other work that makes this even more useful. There's a gem called jar dependencies, which means I can build a Ruby gem right now that specifies dependencies on jars from Maven Central or somewhere else, and that can be pulled into these projects as well. All of my demos, I just want to point this out, are on GitHub under Java 1 JRuby demo. So all of the scripts that I've been running here today are using that. And I also wanted to say that I don't think anyone else up here can say this. Ruby will be at FOSDEM, which is a great conference in Europe next year. We got our acceptance for a Ruby language dev room next year on January 31st and February 1st in FOSDEM. So if you want to vote for the most well represented at FOSDEM next year and greatest scripting language on the JVM ever, then JRuby is clearly the scripting language on the JVM for you. Thank you.
Can I add a small comment? Just very briefly, just one sentence. And the Groovy project is a very happy user of JRuby because we use JRuby through ASCII Doctor for our documentation. That's it.
Okay. So now we go with Clojure. Yeah, that's the one.
Yeah, me.
Yeah, is it on?
Yeah, well, I forgot, but I wanted to thank Stuart Halloway, who's supposed to be here, but I guess schedules changed, so thanks for trusting me. I do want to show a couple things. One is where the community is today, because a lot of you might want to see this, and a couple other demos if we have time with macros and DSLs. So we all know this. It's been a while. It's been a rough edge. Early adoptees, mostly Lisp hackers, very tiny ecosystem, and it was hard for other people to come in, including myself. I was a Java, Python guy, as you said. But is that all? What happens when you bring power? What happens when you bring something that says, like, I don't know what this is, but it seems to make you 10x productive? People start coming together. Seriously. Clojure Cup just finished yesterday. They were about 170 teams, and you should see what they've done. These are the real facts. 12,000 repos on GitHub. Not repos, repo searches. There's a difference, as you know. Hundreds of repos as of today. 500 curated libraries. What I mean by that is these are libraries that have been out there for a few years at least, battle tested, perhaps in production, in 140 categories. Take that, Groovy.
Yeah, but
the world is not web. The world is how
it's
we
one
build
library
things
per
in
parenthesis.
I'm just trying to fun.
Me too.
The clojure.docs just launched 2 days ago. It is one of the best docs you can ever see. Go to it right now. You can search, look for examples. Clojure in production. This is just 3 years. There are more than 24 books. I myself am working on open source book. I don't know when I'll finish. I write like a novelist, so it'll take forever, I guess. Training. Clojure Bridge is this dedicated training for women. Clojure for women. There is a whole group, and it's amazing. You should go check it out. Cognitech, Clojure Conch, local meetups. Ecosystem. Now, I want to mention that when you say community, it's not just a wall community. When I believe that community should be open and not closed, saying that this is the only way to build things. And I found in Clojure and ClojureScript that there are lots of categories. You have your database, templating languages, the web, NLP, the classic web enterprise stuff, and you also have the build tools, the distributed computing, research, real-time, and there is where I'm interested in is the generative art, literature, linguistics. There are packages for all of these today. And I forgot to mention Lighttable. If you're not sure of Emacs or Vim, go with Lighttable. It might help you to begin and might ease your development with Clojure. And also there is, I do want to mention this since we are in a Java conference and I have a lot of experience in the enterprise stuff. I was fascinated and surprised by how many things there are in the enterprise world, including business rules. JBoss just released their server on AS7. You should see, it's a couple of lines. You just run the entire server in a couple of lines from Lanigan, from the command line. Now, I do want to show a couple of demos. One will be a showcase from one of the community members. I mentioned about generative art, what that means. Has anyone worked in HTML5? Canvas? Yes. Do you know what it can do?
Pretty shapes.
Well, never know.
It ought to.
So I'm running a project by Michael. I have the link for this later on, but it's a community project on ClojureScript. He has built a small framework on HTML5 Canvas in ClojureScript, and he did not know Clojure at all. He did this in 2 weeks. This is what power means. This is how people are inspired. And you want to see how that looks? This is less than a few hundred lines of code. And let's not look at this as if it's just some fun playing tool. There is a server running behind this, serving this as a static page with routes. You can inject data into this. I show this as an example of how people are adopting Clojure to solve their own problems. He was a graphic designer. He came from processing JS, and he saw this, and he said, wow, this is awesome. The REPL-based live development is so much more productive. You start creating, not running build tools. That is what is different in Clojure.
1 minute.
And I want to end with this. I love Java. It's helped me for like more than 12 years, and I still work on it, and I'm mostly doing Java 8 these days. The tone of this session is make the future, right? I believe it. I think Java as a platform is the future. But is the future of JVM in one language? No. Don't you think? Great answer. Don't you think you must know the past to build the future? Let's look at our future. Our future. We started with Java, C, C++ in the 90s, clearly in the East Coast. And then this is how things look like. And I haven't included Ruby and Node.js simply because we are speaking of JVM languages. This is all my friends here. I am a part of this. I am a part of this. My question to you, where is Clojure? Guesses?
Okay. So we're done. Thank you. And we switch to our last contestant.
I'm not as religious about Scala. I don't have that passion and religion. That's impressive. I'll give him that. So we have a conference we have several conferences. I can claim that Scala has more conferences than any other language at this table probably, because we're going to have 2 Scala days next year, and there's ReactCon in the fall here in San Francisco, which is a lot around reactive applications that no one else at the table is going to be at. So, wanted to point one thing out. So I'm going to show you a demo. It's available out on the TypeSafe Activator template site. This TypeSafe Activator templates has a lot of demos and sample applications to help you get started with Scala. We put a lot of resources into helping people get started. We think that it's one of the fundamental hurdles to help for developers adopting a language is having good samples and making it easy for them to just install and run those samples. And for that reason, we created Activator and these templates. These are tutorials that walk through how you build these applications, and we think that will really help the adoption by making the barrier to entry much lower for people coming to the application. So I wanted to talk, so I said that Scala enables a new type of application. I wanted to talk just really a little bit more about that. If you think about the type of applications we need to build today, right, they're in a data center, right, you've got cluster computers in a data center, the clusters with machines with JVMs, inside the JVMs you've got nodes, threads, CPUs, sockets, cores, cache. Right, so you think of this layer that we're building on top of, and to be able to fully leverage and maximize the scale and the performance on this stack that we're building on requires this new kind of architecture so we can scale up, leverage all the cores in our CPU, leverage all the memory available, and scale out, leverage the data center and all the different servers in a data center. And we want to do this with the same kind of application model, be able to scale up and out with our same application model. So to do this, we've created the Akka toolkit, and the Akka toolkit really shows what's possible with Scala. I think this really is, there's these new class of applications that are enabled with the language like Scala. Akka is a very powerful concept. It's fully message-based, event-driven. With Akka, the fundamental building block is actors. They're like a Java object that adds in communication. You only communicate with them via messages, message send. And because you're only communicating via messages, these actors have very much of an isolated state. This makes it very easy to scale, very easy to deal with concurrency, because you never think about this. These actors are just managed by the Akka system for you. So Akka is going to manage your threads for you. It's going to manage the concurrency for you. All you do is you create an actor, you hand it to the actor system, and it's going to scale for you. So you never deal with low-level concepts like threads, mutexes, blocking, synchronization, any of that. So this is a much more sane concurrency model. But it's a very much of a different model for building your applications. This is not a traditional request response model. This is a message-driven model where I'm sending a message to my actor and it's giving me a response back in a message. Isolated failure handling. These actors can be isolated and run, underneath like as a child, so we can deal with supervision as a first-class citizen instead of using a traditional try-catch, throw exception kind of model. And then on top of Akka actors are created. You just get a reference to an actor. And what really is powerful about this is I don't care where that actor lives. It can be running anywhere in my Akka cluster, and I can call it. So it could be running on a different server, and I can call it on a different server. So it could be, running locally. It can be running on a different server. So this makes it really easy to scale up and out, meaning that now I can leverage, all the servers in my data center really easily because I don't care where those actors are living. I can send them a message anywhere in that data center. And Akka clustering is a very powerful concept for a couple of reasons. One, it's built on the gossip protocol. There's no single point of failure, no single point of origin, no master. It makes it very easy, a very resilient type of application that can deal with failures really easily. I'm going to show you a demo of an application. So I mentioned Activator with its tutorials. This is a sample on Activator called Reactive Maps. There's a whole tutorial that walks through how this application is built. It walks through all the code. It makes it really easy to see how things work and how things are put together. I'm going to go ahead and fire this up. I'm going to fire it up with 3 nodes. There's going to be a primary place server, and it's going to have 2 back-end clustered nodes running in Akka. So here on my local machine, I've got a 3-node cluster. And you can imagine if it's this easy to create a 3-node cluster on my local machine, what I can create, on a large data center, and how easy it is to create this on a data center.
1 minute.
1 minute. Let's hope that it starts in that 1 minute time frame. So, everyone loves build tools, but SPT gets plus and minuses. We were kind of debating about that a little bit, but the build tool for Scala, it's very lightweight. You just declare what the name, the dependencies, and that's all that's needed for your build. Let's hope that everything is up and running, and we can go to our application. So what this does is it basically shows us on a map all the nodes that are available. Of course, it's not going to start up for me. Oh, there it goes. So you can imagine on this map, we're pushing our position down to the server. The server's distributing across this cluster, and it's aggregating the database on regions. And then when new people come in and want to listen to our data, it knows what cluster node to go on based on regions, and it's going to push that data back up. So what's happening is, this very much of this push-based, event-based model where we're pushing our location down, and then it's distributing across the cluster, and the cluster is figuring out what region we're listening on and pushing that data back up based on our region. So this is very much of that event-based model. Just to show some code.
And I'm afraid we're out of time.
There's awesome code. Look at that. So.
Indeed it is. So I'm surprised that you guys have been behaving like real gentlemen because there were only a few potshots within the languages. Usually at the script ball we have blood and sweat and stuff flying around. But now, instead of things flying around, I would like for you guys to ask questions to our panelists. Panelists, please repeat the question so that it will be on the recording. So who will be first? Yes.
So a lot of the Scala talk was about Akka, which is great. I wonder for the other members on the panel, have they seen any evidence that they can use their languages with the Akka framework?
I mean, from Groovy, you can use any framework without any problem because it's the language which offers the best interoperability between Java-based frameworks, libraries, etc. And we also have a library called JPerf, which offers not just actors, but data flow concurrency, software transactional memory, etc. We've got tons of useful stuff. And they also recently added remoting support for when you have remote nodes on other machines. So we've got that kind of stuff as well on the Groovy side. And we can use Akka as well. I've seen some rare blog posts about that, but that can be done too, yeah.
For JRuby, there's actually a post this morning on our mailing list about using Akka directly. Concurrent Ruby implements some of the concepts from Akka, but there is another gem that's been developed by a member of the community, which I would consider just past prototype stage, called Mika, M-I-K-K-A, and that's a JRuby binding to Akka directly.
I haven't worked much on Akka, but technically it is possible to, bind into Akka from Clojure. But I do know that the Clojure ecosystem as a whole, or a part, they have better alternatives, and Akka is not the way to do. There are simpler alternatives called co-racing and STM and other things. If you have questions, I'm happy to answer it after the talk.
I just want to add that there is an initiative from a team inside TypeSafe. It's called React programming. They have an API, and they are looking for other projects that are using reactive programming. They are openly contributing to the community, and they have reached out to both Groovy and JRuby people that I know of, so that they can also implement these interfaces. So it will be much easier for frameworks that are completely disparate with different languages to share the same...
reactive streams.
Yeah, yes. That's the one, reactive streams.
We heard about the Scala conferences. I'd like to know what do we have available for other languages here, Groovy.
Yeah, for the Groovy community, we have different conferences across different continents. So there's the Great Conf series, which happens in Europe and in the US every year. So in Minneapolis, actually, for the US variant, and in Denmark for the one in Europe. There's Greach also in Spain. We have Groovy Grails Exchange in London. And again, in the USA, there's Spring 1 to GX. So it's Spring stuff plus Groovy Grails Gradle stuff. And we've had some other stuff elsewhere in Australia, Japan, but not as frequent as these other ones that I mentioned. So several times a year.
So on the Ruby side, in case anyone's curious, that's Charles Nutter, one of the core contributors to JRuby, trolling from the back. You probably have a better idea of the conferences than I do, because Red Hat will send you. But there's Ruby Kagi, which just happened last week, I believe, which was a lot of the sort of core members of the Ruby community getting together in Japan. Over the summer, we had EuroCamp in Berlin, which was also a very good event. The Ruby community is I would say...
Oh, the JRuby Conf as well?
JRuby Conf EU, that's the shirt I'm wearing right now, actually. The Ruby community is sort of very vocal and very tight-knit. There's regional conferences, just about everywhere, at least once a year. Here in the San Francisco area, we have Goruko, which is the Goruko, which is the Golden Gate Ruby conference, which may have just passed. I don't remember. But Ruby conferences are very widespread. If you want to go find them.
So for Clojure, Clojure Conch is the biggest. It happens in DC in November, 2nd or 3rd week. This time it's November 22nd. I heard you should go. It's affordable. It's a lot of fun. I went there last year and I had a blast. In fact, someone taught me macros after a beer and I was just blown away. And there is also Clojure West that happens in the spring in the West Coast. And apart from that, there is Euro Clojure, a couple of smaller ones in Spain, I think. But I think it's picking up. It's, I would say, relatively lesser than Java.
Strangeloop has a lot of Clojure too.
Strangeloop. That's more on the bleeding edge stuff.
Scala Days, next year we have Scala Days in March in San Francisco, in June in Amsterdam, and then we're at about every conference there is. So we're at Strangeloop, Java 1, all the main conferences.
Also, NFJS, this is probably for all of us. NFJS tour is happened mostly in the East Coast and also Midwest. They have a lot of Java, Groovy as well, and Clojure and Scala are picking up.
Yeah.
So we have time for one more question, and then we decide the winner. Yes?
Yeah, it's a pretty wide question, but I'd say in the Groovy community, we've got a few options. So the traditional solution would have been to use Grails, the Grails web framework, which builds atop Spring and other interesting components. For reactive kind of applications, there's the Ratpack toolkit and framework, which is built atop Netty, and which supports the reactive stream solution that we mentioned earlier. And we've got some other smaller things, or dedicated things, for example, Gaelic for applications on Google App Engine, etc. We have different options, but the question is quite wide, so there are options depending on what you want to do or which platform you want to deploy on.
On the JRuby side of things, I probably wouldn't start with Rails. The way that a lot of the world seems to be moving is with more thicker, richer JavaScript applications. So I view a web server much more as an API server, to where Sinatra would be my go-to. I've also heard really great things about what Finagle can do and what some of the guys at Twitter are doing to build these API servers as well. But Sinatra deployed on Jetty with JRuby is kind of my go-to gig right now for building backend API servers to power these JavaScript web applications.
So with Clojure, there is a core library called Ring and Composer, which is like Sinatra. It's been out for a few years, 4 years now actually. It's perfect. It just works out of the box for services. And for the web front-end side, there is ClojureScript, there are Ajax libraries, there are React OM libraries, there are templating languages. And I can tell you that none of my colleagues here can speak about that because they don't have ClojureScript. You still have to use JavaScript.
We've got GruScript.
But no one uses it. So with ClojureScript, it's like Node.js, but with the power and simplicity of what Clojure can potentially offer.
But it won't scale. But
we'll have a battle after this.
Okay, so finally.
But
I just happened to. My next slide was a future architecture slide. So, really quickly, basically a play server, completely stateless, so you can scale it horizontally.
He's back into slide.
Yeah, we're going into a backend Akka cluster. So this is kind of the future we vision, and the play has native web sockets. So
show us an app.
Okay, well, so before we decide the winner, please let's give a big round of applause to our panelists. Thank you very much. I hope you have enjoyed the session. So now you will clap, and the one that is the language that receives the most noise will be declared the winner. This is totally scientific, okay? It depends on if I hear from the left or I hear from the right. Okay, so let's hear it for the first one. Groovy. JRuby. Crusher. Scala.
Let's go!
Okay, let's try it again. Groovy! JRuby! Clojure? Scala! Okay, so it sounds to me that it's between Groovy and Clojure, right?
Yeah!
That's the spirit.
Who likes both?
Okay, so one final round, and I'm going to do it the other way. Clojure! All right. Groovy! It sounds to me that it's a tie, isn't it?
Show of hands, maybe. Count.
Show of hands. We need something to calculate.
I will write a function right now.
Can you do it in less than a minute? Okay. My scientific research determines that this year will be a tie between Groovy and Clojure. Thank you very much for participating. We have another session similar to this in 1 hour. It's called the Emerging Languages Script Ball. If you're interested to know in other languages that in the future might be here on the big stage, just come in the next hour in the same room. Thank you very much. That's a good one.